course, we all know that it's impossible to have an infinite array because your computer memory is limited. Irregardless, this is a module I wrote about a year ago. It's part of my runtime, and it's a version 1.0 module like a lot of my stuff is. And it's not been used very much, but let's kind of check it out and see what it can do here. If you're not familiar with my template here, all it is a little console window that says press enter. And that's our starting point. So, what I'm going to do, I'm going to declare a local variable. It's going to be in the static data section. It's going to be the infinite array object, and I'm going to, or module, and I'm going to name it my array. And let's go down here, and we're going to invoke my array dot code 4 little functions. I'll tell you right now, we're not going to use get next element, so forget like you see that, but it's open, close, and get element. It's actually very simple. Let's see what open does. Element size. Okay, how big do you want each array element? I'm just going to make it 8. Optional. Number of elements. Okay, it's optional. I'm going to leave it out. Alrighty. Let's start the top of a loop. I'm going to indent. Get numeric input. What array index do you want? We're going to be running the get element function. It should come back with the number in RAX, what the input was. We're going to, if it's equal to 0, that's going to be our exit of the loop. I want to save the index into a variable called index, which doesn't exist yet, so let's go make a variable called index. Now it exists. And let's go ahead and do the myArray.code.getElement index DQ. Perfect, I got it DQ named index. So what that should give us is a memory address of our array element. And we should save that to a variable that doesn't exist yet. Let's see. So let's see. Let's echo a few things out. I just do a write. That's gonna leave everything on one line. Right line. This will make a new line. Address. We'll echo those out. Now, this right here would be the else for that jump equals condition. I go back 2 more, and this is going to be the loop jump. That's going to jump to that point there. This jump equals, it's going to land right here. Invoke myArray.code.close. That closes down the memory and clears it all out. Now, the myArray is a static object. So, but when it opens and closes, that's for the memory that it pulls off the operating system. After it closes, it's still a static object. It's in program space. It'll never die. And that's how that works. So let's give this a shot. Oh, doesn't like that. Let's compare it to 0. Let's try it again. Okay. Let's run. What array index do you want? Let's go with 1. Index 1, that's a memory address. What array index do you want? Let's go 2. Now that memory address is 10 away from the first one. So even though our element size was 8, it gave us a 16-byte aligned address. So it kind of wasted 8 bytes, which I'm fine with that. It's going to be all the addresses should end in 0 then. That'll be aligned data. That's kind of a good thing. Let's go to index 10. More addresses. Let's go to index 100. More address. Let's go to index 1000. We get an address 10,000. Okay, so you get the idea. I call it an infinite array because I never had to declare how big the array is, but you can pull a memory address for an element of any element number you put in there, which is kind of cool. What's also neat about this, the most important part, is that normally in like a situation where you do a malloc and a realloc, the realloc will take your memory and make another memory block that's larger, and then it will copy everything from the first block to the second block, and that can give you program delays when you're doing that copying and lag. So that's one kind of nifty thing about this, is it never copies anything to a new memory block. Even though I put in index of 1000, the address of the first index is still the same. Let's kind of check that out a little bit. What I'm going to do next is I'm going to go up here. I'm going to comment out main. Infinite array. Okay, so these modules that I have in this compiler, they kind of have a duality to them. What we saw in the first example there in main is how the infinite array can be an object and what functions are available for the infinite array object variable. But the infinite array is also a module that has functions that are not really part of the object, if that makes any sense. So if I just type in infinite array and hit dot, it has the code, static data, enums. We're going to look at the code that's available for the module, infinite array module. And what these are is these are kind of like, this is kind of where I put like my testing or a troubleshooting or how to kick a report out on the object. Kind of behind the scenes functions that they're not private, they're actually public, but you don't access them through the object, you access them through the module namespace itself. I'm just going to run test 1. And run test 2. And we're going to kind of check these out a little bit. Okay, so test 1. You may enter any element index you want and the array will attempt to expand, and you don't need a period there, to expand and provide a memory address for that index. This OIA is my object variable, Not a very good name, but that might be the address of the object variable itself in memory. Infinite array on heap. All right, so that's the heap that's been allocated by the object. It's 4,096 bytes, which is one page size. So the default is to give you a chunk of memory that's 4,096 bytes. And that's the smallest memory chunk indexable. And which array element do you want? 0 to exit. Let's just get the first one. Index 1. There's the address for array element 1. It's actually kind of really close to that number. Let's go 10. I think this number here is actually the memory address of the memory block of that 4096. And the first portion of that block is going to be another infinite array object. So what's kind of going on here to make this magical infinite array work is that it's a kind of a recursive objects. So one object could be like a parent, one could be a child, and then the child can have another child, and that child can have another child. So what you have is blocks of memory that are in serial kind of. So your array is actually strung out into multiple blocks of memory, as many as needed, which is and it's just managed, and the object just manages the indexes and the variables and the counting all for you to make it all just some neatly packaged, real easy thing to use, which is kind of cool. And this test here will kind of show a little bit more. Let's give it a bigger number, 1,000. Let's give it 10,000. All right, we're getting addresses, and now we hit 0. It's going to give us some reporting at the end, which it already went into test 2. But which array element do you want? 0. So what it did is it ran the report, and what it is each one of these rows is an infinite array object reporting on itself. So the first one was 4,096 bytes, but the second one was bigger. So when we asked for a larger array index, it said, okay, I need to make a bigger chunk of memory. Then we went way further down. We got the biggest chunk of memory possible. And I think we're getting such big chunks of memory so fast because I think my element size was 100. So they aren't small elements. They're big elements with big numbers. And that's kind of what's going on. And it says there's 7 objects that were created. Lost my window. My window keeps disappearing on me. It's a little glitch I have. So I got my debugger in the background. I'm just going to leave it an empty screen. Okay, so total size of memory about 2.5 million bytes. That's adding all these objects together. And now we're going to test 2. And this verbiage here kind of goes a little more in depth than I wanted to. I should have kept it simpler, but this is kind of like more notes for my future self. But this is an infinity test proving that memory is not recopied. An infinite loop will write self-pointer data to each element, but doing this will method generate. Oh, nice. Will method generate the smallest page size of memory chunks, and like what it's meaning is see how we jumped from give me index 1, index 2, give me index 1,000, and then once it jumped to 1,000, it said, well, you want index 1,000, I'm going to give you a huge chunk of memory for that one object. Well, this is going to go a loop where the indexes will be asked for in order: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and when it does it in order, it's only going to make each one 4,096, just one page. So each infinite array object will just be 4,096 bytes, and that's kind of the point of the experiment. Is it's going to have a little bit of inefficiency here once overhead recursing through these objects. So create large number of descendants. This will cause lag requiring the address for each index. but as an infinite array with data that is never relocated, you will be prompted to enter an infinity index. This will allow for premature exit of the loop. So an infinity index is how to exit the loop early. Let's go. Let's say 1,000 is infinity. What it did is it went through and asked for each index, each element, one by one, and it made a self pointer, wrote to that data of its own address. And it did another loop where it checked all the self pointers at the end to see, just to make sure that memory wasn't moved or recopied somewhere else. And it was originally intact. Number of infinite array objects was 5. Total size of memory is 20,000 bytes. And it didn't kick out a report of the objects, which is I'm okay with. So let's do it again. Let's go 10,000. Now you see that at 10,000, it's still kind of a quick. It was just a blink. So we had 10,000 elements in an array and not really lag. But if we go up to 100,000, there's a little lag. 402 infinite array objects, all the smallest page size possible. So you get to see a little bit of lag there. 0 to quit. Press enter. Okay. Well, that's basically the version 1.0 infinity array module object. It's kind of cool. It works. It's kind of handy. It makes things easier for the programmer because you don't have to worry about your upper bound of your array running into memory that you don't own. It will ask for as much memory as your computer will want to give you, and it's pretty cool. Thanks for watching.